Section 5.3, dividing polynomials. Now this gets a little bit tricky only because polynomials are pretty complicated. They can have a number of terms. We don't like to deal with anything past 3 or 4 in this case though, or else it gets a little bit ugly. But let's go back to 4th grade and divide, let's say, 10 into 520. Now the first thing we did was take 10 and see how many times it went into 52. And it goes in 5 times. And then we multiplied. 5 times 10 is 50. And then we subtracted. And we end up with 2. Then we brought down that 0. And how many times does 10 go into 20? 2. Multiply. Subtract. When we got 0, we were done. If we got a different number than 0, we would put a remainder. And then we would put that in that box there. Okay, so that was a little bit of a flashback, and the rules are exactly the same when we're dividing polynomials. So let's say we wanted to take z squared plus 2z minus 24. We wanted to see how many times z minus 4 went into that. Okay. We're going to first just concentrate on this first monomial of the polynomial, and the directions here are divide. Okay, so we're going to say how many times does z go into z squared, or what times z gives us z squared. And that's going to be a z. And then we're going to multiply just like we did up there. But we're going to multiply each term. We're going to distribute. And we're going to write it right here on the bottom. Z times z is z squared. Z times negative 4 is negative 4z. And then we do the same exact thing. We subtract. Now it's really important to remember that we're subtracting. These two go away naturally, just like the 5s went away there. And we take 2 minus a negative 4. This is where we have to kind of step aside. 2 minus negative 4 and make sure if we're subtracting a negative turns into positive. So we have a 6z. And we bring down the negative 24. And we do it again. Focusing on these first terms here. What times z gives me 6z? And that would be a positive 6. And I multiply and then subtract. Now when we have the same things written here, those go away and so do those, and we have a remainder of 0. So our answer would be z plus 6. Now that's long division. In order to shorten it up a little bit, we use what we call synthetic division. Okay, it's a little shorthand way. So let's say we have the same problem. Z squared plus 2z minus 24, and we want to divide it by z minus 4. The way we set this up is we have a box, a big equal sign, and another box. This part here is going to coincide with what we were dividing by, but we're going to change the sign there. So we're going to put a 4 in here. It's exactly like we were to solve this for the variable, and that's the number we put here. This is our remainder box. And if we do it correctly, we're not going to have any remainder because we saw it went in evenly up there. But we're going to take all the coefficients, so none of the variables, just the coefficients. We have a 1 on the first monomial, a positive 2 on the second, and a negative 24 on the third. We always want to put the last term here right over the remainder box. If we're missing any terms, we have what's called a place value. Say that was x to the third, x squared, and then we didn't have any x's and it went straight to the numbers, we would put a 0 there as a placeholder. Same as if we skipped an exponent in the long division part. So the rule here is we bring down the first one, just like always, and we take those two numbers, multiply them, and write them there. Now here's the difference between long division and synthetic division. When we go down, we always multiply when we are going up or down like this, but when we get down into here we're subtracting. In this case we add, so we're going to add those two and get 6. Then we do the same thing, multiply, and then we add those and get 0. We are left with the coefficients of our answer. So we started with z squared, we're going to end with z plus 6 with no remainder. And we get the same exact answer.